Hey everyone, Aditya here. Welcome to my channel. Today we're going to discuss about system design interview preparation. So, what is system design and how to prepare for an interview? We're going to discuss now. Unlike normal system design course, right? I am directly going to design a system in my course. Okay, so I will start with introduction. Usually, system design interview starts by asking some vague question like design Netflix, YouTube, or anything, right? So they will ask any some vague question. So we can say it's an open-ended question, and we can't build entire system in that interview itself. We can't build entire YouTube or we can't build entire web WhatsApp in that interview itself. So before you are trying to solve or before doing your design, you have to focus on few important areas before proceeding further into your interview. So we will discuss regarding those in detail in this course and also learn how to build different systems which are scalable, okay, and highly available and low latency. What is a scalable system? Scalable system is a system if the user base increases also it will able to handle those. And highly available is the system which promises less downtime, right? We don't have any downtime. And low latency system which promises you will get responses quickly. So that kind of system nowadays everyone looking for that kind of system designs, and in this session we are going to discuss about those things in very detail. Now, we will start by an interview itself, like design a task list application. So, an interviewer asked a question like design a task list application, and he has given a description vaguely like this: a task list application for users who wants to track their tasks. It is simple. So, I am a user and I have few tasks like I want to do coding, YouTube course, and I have to do some other work, right? I will add those tasks in this application, and once I completed, I can mark it completed. So so they will add the tasks, modify them later, and mark them completed once done. So that is the basic working of this task list application. Now we'll see how to design this application by focusing on important areas which are required to complete or to design the system. Now, before dwelling into your system design, first thing you need to ask or first thing you need to do is requirement gathering. So before starting your design, you have to ask questions to the interviewer regarding the system. So what kind of questions? So we have divided that system design into two categories. One is functional requirements, another one is non-functional requirements. The functional requirements is the thing where you have spent most of the times, right? One is the core features. In the functional requirements itself, we have two categories. One is the core feature. The core feature, the core feature is the thing or the problem we are solving. So the users can able to create, modify, and delete the tasks. That is the core feature of the task list application. And what are those that support features? The support features, these are needed to solve the core feature. So without these support features, it's difficult to solve the core feature. For example, without a list, how can I select in a task and modify and delete it? No, right? So we need a list. And also we need task list per user. For example, for me as an user, I have separate tasks. For you as a user of the application, you have your own set of tasks. So this application allow each and every user to add their own set of tasks and view them as a separate list which was visible to them only. And each task has a name. Definitely a task should contain its name and description of the task and due date, right? So these are the functional requirement. You need to ask these things from the interviewer and note down like this. And the next one is the non-functional requirements. Anyway, this is common nowadays. The interviewer definitely asks for an highly available, scalable, and low latency system. Now, apart from this functional and non-functional requirements, the important aspect or important thing you need to ask is scale. So, as a part of requirements gathering, we have already know what is the functional requirements and non-functional requirements. Now we need to know scale. So what is the scale of the system? So for that, you need to ask four basic questions like how many active users per day. So how many users using that application per day you need to ask, right? So they will give around some estimation like 500. And how many tasks can be created by a user per day. So like how many task like modification creation task can be created by user per day, maybe 10 tasks. They will give some number. And what could be the size of each task, right? Each task could be what size, like it is holding some text description and date information. Maybe it could have some size, and this size could be helpful for calculating future storage, right? So that's why we have to ask this question also: what is the size of each item? Right here, task that is 20 KB, maybe they will give that size for you. And also ratio of reads and write. So this is also very important scale measurement. You need to ask whether to define your system is more dependent on reads or more dependent on writes. So here if you see, it is clearly visible it is more dependent on reads, because per day, per person per day is doing 2 reads and 1 write operation. Okay, we will look into another important aspect or important area in the system design, that is capacity estimation. Earlier, we have looked at the first step, that is requirement gathering, and in the requirement gathering, we got core features and support features, right, in the functional requirements and non-functional requirements along the scale. So once you get the scale, using that scale, we have to calculate capacity. So it's just an estimation. So for that estimation, we need to focus on three main areas, that is request, bandwidth, storage. So here we will calculate an estimation of capacity of the system, so that will handle the user base based on our requirements. Okay, there are three KPIs. Here KPI means key performance indicator we need to focus. That is one, request, second, bandwidth, third, storage. So these three KPIs will determine your system whether it is efficient or not. So we need to calculate now these three key performance indicators, so that based on that we can scale our system or design our system, right? So first we'll dwell into it. The first KPI is requests. So we'll see how to calculate this request based on the information given by the interviewer. So the interviewer was given the information like this: number of daily users as 500, number of tasks per day per user is 10 tasks, size of each task is 20 KB, and read and write ratio is 2:1. So here you don't get confused. For every day 500 users log into the system, and each user do 10 tasks. So for example, in our company we have 500 employees. Each employee log into that task list, and every day we'll do at least 10 tasks. Okay, so and each of the size of the each task should be 20 KB, and read and write ratio is 2:1. That means every day there will be two read operations and one write operation. That can be possible. Now we will see how to calculate read request and write request per second. Use the above information. Okay, we have 500 daily users, and they will do, each user do 10 tasks. That means 500 to 10, 5K requests per day the application will get, right? So we will convert this request per day into seconds, right? So if we do that, we will get some X RPS, that is X request per second. Okay, now we will calculate write and read requests. So we have this ratio: write is to read, read is to write. So for every two reads we have one write, so that is the ratio. Now we have request per day we have X RPS requests. Now we will calculate. So since the write ratio is 1, so 1 into X, that is X RPS. So per second our write request is only 1X, and per second our read request should be 2X. Okay, 2X RPS. So X value, so here the X value should be something we calculated by converting this value into seconds, but I am not going so deeper here. I am just roughly explaining how the capacity estimation should be done, but in the future videos you can able to see how we calculate them within our mind itself instead of using any calculator. Okay, now the second KPI, key performance indicator, is bandwidth. So again we are going to take the information given by the interviewer along with the previous estimations, that is reads, we have read request for X RPS and write request to X RPS. Now we'll calculate the bandwidth. Here we need to add both read and write request. Why? Bandwidth in the sense both upload and download, right? We are uploading means we are writing some requests. Downloading means we are reading some requests. So that comprises our bandwidth. So I am adding both the read and write requests. So which will give us 3 3x RPS. X RPS plus 2x RPS will give 3x RPS. So this 3x RPS is total requests, right? Both download and upload and download value. So by using this upload and download value per second, we are dividing into the size of the each item. So per second we are uploading 20 kb, right? 20 kb into 3x RPS. So which will leads to 60x kb per second. So this is the bandwidth. So this was the network we need. So our network should be greater than this 60 into 60x kb per second. Then it will be good, right? Of the bandwidth estimation. Now we will see how to estimate the storage also. For storage, we are going to take the same information given by the interviewer, and also we're looking into our previous estimates, that is requests. So request we have two types: read request, that is xrps, and write request to xrps. And also bandwidth we calculated, that is 60x kb per second, right? Now how to calculate the storage? So storage estimation, how could we do that? So for storage estimation we have to take write right RPS, right? Because no need to consider the reads here, we have to take writes. So here writes we have 2x RPS. So 2x RPS into how much? For each item the size is 20 kb. So 2x RPS into 20 kb, which gives you 40x kb. So this much amount of um, data you are storing every second into the system, right? This is the storage. Now we need to calculate this storage into MB, GBs, for better understanding. And also we need to calculate for more than 5 years, right? We have to calculate this information for more than 5 years, because storage could be estimated for the long run, right? The application you should always think about, it should run long run. So almost estimate for at least 5 years storage. So this and all some basic estimation techniques I am showing, but in future videos I will show you how to do this in a more efficient and effective way. Okay, now we will move into another important area which we need to focus. So we have already seen the requirements gathering, and after that, from the requirements, we have arrived at capacity estimation. And once you complete the capacity estimation, the important thing is you have to do data modeling. Okay, the next important area you can say data modeling. So in the data modeling, we will use the functional requirements which we gathered from the interviewer at the starting rate, the core features and the support features. We will take those. From these we will get our data modeling. So here data modeling is nothing but finding the uh, database, right? You need to find a database to store the information. But as of now we are going with a relational database in this introduction. But in our progression in this course we will see the n number of data modeling and databases. Now, as of now, I'm going with relational database. Now, if you see here, how to find out our entities now. So, data modeling is nothing but we need to find three things. One is entities, another one is relationship between those entities, and the third one is the attribute of an entity. So in order to find a relationship and attributes, first you need to find the entities. So in our task list application, our entities are two things, right? We are going to solve this problem, that is the core feature, where we need users. So we need a user entity, and also we need task task entity. So we need two entities, one is user, one is task. So we got the entities. Now we have to find out attribute of an entity. So how can we find an attribute of an entity? Here you have users, so we can say an user, right? Usually an user may contain user ID, username, right? And also the task ID which he belongs to. right? The task he created, the particular task ID, maybe other information like address, user location, and you can store a number of things. But basic things is you need a user ID and what task is going to tag, right? Because we have task also, the task ID. So user ID, task ID is enough. You can add username also. So this is basic and attributes of a user. And we have task. Now, when it comes to task, so what a task should contain? So we know a task should contain name, description, and due date. So these three things should be come under as an attribute of a task, attributes of a task. Now, along with it should contain the user ID also, right? So to which user this task is tagged, right? That thing also we can track by using the user ID. Now, the task has all the attributes like task ID, task name, task description, due date, and user ID. And users also has their attributes. Now we'll create a relationship between them. So what is the relationship between them? An user can able to create, modify, and delete tasks. So the relationship between them is the creation, deletion, modification, and updation. So these three becomes a relation between these things. So that means, right, a user can create a number of tasks, modify a task, delete tasks. So that means we can clearly say the relationship between user and tasks is one to many relationship. One user can do many tasks and many updates and many deletes, right? So we'll see. We have users who we need to a table to store user details. We have tasks, we need to use another table to store task information. Now, if we say user as entity table, we may contain new attributes like user, username, ID, etc. Also for task entity table contains attributes like task ID, task name, task description, task due date, etc. along with user ID also. Okay, here we can relational database as of now, and clearly we can say one user can contain multiple tasks. So it is one to many relation. Now we will start our data modeling. We know how many tables to create and what kind of database we are going to use. So as we discussed, we are going to use an relational database. So once we decided about the database, now we are going to create the entities, right? We need an user entity. Along with we need an task entity, right? And we are going to store these entities in the relationship database. And also user entity has some attributes like user ID, username, task ID. So here user ID is the primary key, and the task entry should have its own attributes like task ID, user ID, task name, task description, due date. And here the task ID is primary, user ID is the foreign key of this user entity, right? And here the task ID is the foreign key of task entity. So like this, you can do your data modeling, which is an important area after capacity estimation. Now we will move to another important aspect of our another important area of system design, that is API design. As of now, we completed data modeling where we had an decision where where we already taken one decision using relational database with which entities, right? Which entities we need. So that was completed. Once data modeling completed, you can start your API design. So what is API design and how to start your API design? Okay, so APIs we know, right? What are the endpoints we are going to give to the client so that they will hit that endpoints, they will be able to get the response from the system. So from these functional requirements, so we need to concentrate on functional requirement here also. From the functional requirements point of view, we need to calculate we need to design the API. So if you see here, the users can able to create, modify, and delete the tasks. So I can say first API should be the create, right? Create task. So an user can create a task. So in order to create a task, he needs some information like what is the task name, task description, and task due date, and maybe the user who is going to create the task, his ID, right? By using this information, we are going to store the task information in the task entity by using. So whenever the client hits this API, the a new task has been created on his ID. Now the other API could be the modify task. So whenever Then user want to change his task, so he will send the task ID along with new details. Maybe here we can add due date also. Okay. And for the third one, we can delete a task. So whenever user don't want a task, he can able to delete, right? And the other one is the get task, right? So whenever user log in to the page, we want to show a list of tasks, right? So at login itself, we will call this API get tasks, where we will pass the logged in user ID and which type of sorting we want and which type of paging we want. We will provide those information, right? Otherwise, you can simply provide user ID and get the task instead of this sorting and paging information. That thing also we can do, right? We can use this get task API. We can use this get tasks API. And the final one is get task. So once we have a list, right, we want to open that, we want to enlarge that task, right? We can use this get task. So for getting only one task instead of getting a list of tasks. Based on the core features, we can able to identify our APIs and design those APIs. Okay, we will move to the next important area of the system design. We have already seen API design, how to design APIs based on the functional requirements. Now we are actually diving into the system design, how to design a system using the available information. So we know we have required information to design a system. Now, first we need to learn few symbols which are needed to do a system design. So this part is the system design itself, the next area, the next important area. And no, you need to learn this or you need to know this symbols in order to complete your system design. Okay, so look at this symbol, right? This symbol is usually a service which is the one which serves all the operation related to particular component. Okay, so any service, for example, we have take user service or task service. That service will do all the operations. Main business logic has been executed inside the service. For example, storing, getting the data. Once receive the data, once we send data to service, service will process the data and store to the database. So even creation, deletion, or modification, right? For example, user service handle all user creation, deletion, and task service handles task related work like create, delete, and modify or show list. So that is the purpose of a service, and this symbol represents that service. And after that we have database. So database has been represented by this symbol. And what is the use of database is to store, right? In service will process the data, but where to store the data, where to persist the data, we need a place to persist the data, right? That is the database, and this symbol is used to represent the database. And next one is the clients, right? From where we are getting the input, right? The clients from the globe, maybe he may be a website or maybe a mobile application. So there will be a number of clients, they will send requests to our system, and system will take that request, right? To represent that clients, we use this. And we have another symbols like these arrows which represent the flow of data to one, from one to, like the forward arrow represents the data is flowing towards that direction, the backward represents that we are getting response from the particular component or service, right? Or database. And here it's a load balancer. So here each node is an request. So it will take all the requests from the clients and it will store, and it will find out which service is free and which service is able to execute at that point of time. It will distribute that traffic to service. So it will take the traffic and it will distribute based on the available services. Okay, so these are the essential or required symbols you need to know. Now we will dive into our system design. Now we'll see the hands-on. So how to do a system design. Now we'll try to understand what we need to do. So we have a client. From the client, we are getting a request to our user service, right? To store an user information. What we will do, we'll store that user information in the database like this. And now the user wants to create a task. So they hit the task service, right? And they will store the task information in the database. So sim like this, the client's interacting with the service and service is storing data into the task. Now, if you observe this design, right, we designed our first system, but if you observe this design is not scalable. So how can we say the scalable? Because we have all the single point of failures. For example, here we have only user service. What if this user service is down? We have only task service. What if this task service is down? And what if here we represented only single request. What if the client is sending more than 1,000 requests, and how this load can be handled? And also, if you see the database, currently it is also a single point of failure since we have only one database which is storing users and tasks. So this is not a scalable system, but this is a basic system where clients sending information to the services, and services is the main area which processes the business logics, and those business logic information has been persisted in the database. So this is the basic system design, I would say. But in order to make this system scalable, what to do, we will see now in the next slide. Now, how to make this design scalable? The first thing is we are getting info requests from clients. Now assume you are getting more than 1,000 requests. So all the requests, instead of directly sending to service, we will load into an load balancer. So these are the four requests, for example. So this four request has been loaded in the load balancer, and it will send to our service, right? But we have more than two requests. So now this one service won't handle this much traffic. That's why we spin off multiple services. That multiple services spin off will represent like this. So this is called horizontal scaling, and we can add services like this, n number of services like this. Okay. So now this load balancer will find out which service is free and which service has less load, and route this traffic to that service. For example, here we have four. Two requests went to the below service, and one request went to the forward service. Once the service processes these things, they will write that data into user database. Right here, user has a separate database. Now, what if the client hit for tasks? So similarly, if a request come to the tasks, right, clients send a request to the load balancer, and load balancer route the traffic to task service. So in order to scale the task service, we will use this representation, which shows it's an horizontally scaled. That means based on the load, the number of services could be increased, so that we'll process those services. And once processing completes, the information stored in a separate database for the tasks. So here the task database is independently scalable, and the database of user can be independently scalable because both has been in different position. So if the user service is down for some reason, we are not dependent on anything. The task service will able to get the task from its own database, right? And if the tasks is down, the task database is down, but we will get the user information at least. So this is not a very perfect design, I would say, but this is our first design, which is scalable, which will work for the most of the times for the small, very middle, small apps. But yeah, we have completed our first system design, which is scalable. Final important area is design discussion. So you completed your system design. So all the first five steps, right? Requirement engineering, capacity estimation, and data modeling, API design, and system design. All the five important areas. And after that, we have the sixth important area is design discussion. This is where the interviewer and you has a discussion regarding your design. So you guys will talk about the trade-offs of the design. What is the trade-offs, and what is the bottlenecks? What is the cons and advantages and disadvantages? You need to explain all the things about your design to the interviewer, and any further improvements needed. So you will have to think about any further improvements or anything. Instead of making changes in your design, you may orally explain those things to the interviewer, and you and interviewer will have a deeper discussion here to test your knowledge and different questions related to design decisions. So as of now, we are not going in deeper here. In the future videos, we will discuss this thing very much deeper. But one thing you need to remember is here the discussion mostly on your knowledge on the system design, and how to scale your system, and how to take different decisions, like how to compromise on few things like scalability or availability. So those kind of things, right? And different kind of aspects will come into picture here. But design discussion is simply a discussion between you and the interviewer regarding your decide whether there is any bottlenecks, trade-offs, or any further improvements needed, right? A deeper discussion definitely you both will have. There is no such thing called perfect design. So you try your best and try to showcase your design skills to the interviewer, and we'll see design to the interview. That's it. So there is no perfect design. So in the future videos we will discuss about this in a much deeper, but as of now this was an introduction, so we will leave from here. So we will stop the introduction here, and thanks for watching my video. If you like my content, like, share and subscribe. And if you want to know any particular concept, try to add in the comment. I will try to create a video regarding that. And thanks for watching my videos. Bye.